focus more on the vertex form, and tomorrow we'll talk more about standard form. But we want to be able to graph a quadratic equation. We want to be able to find the vertex and the axis symmetry. Using the information, we want to be able to make a decent graph. And we're also going to write equations given a point and a vertex for a graph. But you need to know this form. And so the first thing that I wrote out here for you is this is standard form of a quadratic equation. When we do the quadratic formula, or when we complete the square, or when we factor, we usually think of a quadratic like this, ax squared plus bx plus c. But there's another form of a quadratic equation that maybe you have some memories of, which is this. Y equals a times x minus h squared plus k. If you remember Algebra 2, you did conic sections, and all the conic sections you wrote out with h and k. So what's nice about vertex form is if it's in vertex form, you can tell the vertex and the axis of symmetry by just looking at the problem. The vertex is always the ordered pair HK. Notice the formula is x minus h, so you have to take the opposite sign for h, but k, you take the sign that's there, so we'll talk about that as we go through there. The axis of symmetry is that line that cuts your parabola in half. It's always on the vertex and it's vertical, so x equals h is your axis of symmetry. And just like in standard form, A tells you whether the graph opens up or opens down. If A is positive, think about x squared. If it's positive, then your parabola opens up. But if A is negative, then it's going to flip your parabola over and it's going to open down. You can also use those rules of transformations when it's in vertex form, where this would move it up so many units, this would move it left to right, this would stretch or shrink it. But you can also just make an XY chart. So if it's in vertex form, it's great. But what happens if it's not in vertex form? We want to put it in vertex form. So my directions here say write in vertex form, state the vertex and the axis of symmetry, and maybe we're going to graph it too, since I have a little graph over here. So here we go. There's our form. Y equals a times x minus h squared plus k. I need to take this and make it look like this. How do I take something that's not a perfect square and make it into a perfect square? Maybe I need to complete something. Complete the square is how you make something that's not a perfect square into a perfect square. So we got to think a little differently on this problem because we're not solving it, right? Normally when we complete the square, have we completed the square this year? We have, haven't we? Normally when we complete the square, we take this and we subtract it over to the other side, right? I can't do that in this problem because y is over there. I need to keep y by itself. So on these problems, when you complete the square, I always just kind of group these together and leave a spot to complete the square and just kind of kick that plus 4 out to the end. And if you think about vertex form, that makes sense because you always have that plus k out there, so it makes sense to have some number out there. And then the whole point, or the whole process of completing the square is we do what with this middle number? Divide it by 2 and square it. So half of negative 2 is negative 1, and negative 1 squared is 1. And again, when we solve equations, when I add 1 here, I add 1 to the other side, right? I can't do that on this because there's y. So what could I do out here that would undo adding 1? Subtract 1. So whatever you do on the inside, you do the opposite on the outside. Memories of this? And really, that's completing the square. We're just going to kind of clean it up now. We want to write that as a perfect square. And you could just factor it. What multiplies give me 1, that adds to give me negative 2. Or remember, it's always going to be half of that middle number. So half of negative 2 was negative 1. So that's going to factor into x minus 1 squared. And then the outside, 4 minus 1 is 3. So what is the vertex of this? HK. Remember, it's x minus h. So you take, kind of think about, take the opposite sign of the inside, but you take the sign of the outside. So the vertex would actually be 1, 3. And if you think about transformations, Remember, like a -1 actually means it's moved right 1, so that's why you take the opposite. And a +3 means it's moved up 3, so we've taken that parabola and we've shifted it right 1, up 3. The axis of symmetry, don't just tell me that it's 1, it's an equation. It's the line x equals h, which is x equals 1. Let's make a little graph. This is where knowing the transformations helps. It's the same x squared graph we've always graphed. We're just moving the vertex. Instead of starting at 0, 0, we're going to go over 1, up 3. If you don't know what the graph looks like, then you can pick some more points. Pick a point on either side of that. But remember, normally on x squared, when you go over 1, you go up 1. So you can do the same thing on this. We could go over 1 and up 1, over 1 and up 1. And we can get a pretty good sketch of our graph. You don't have to graph the axis of symmetry, but just to remind you what that is, that's that imaginary line that cuts through the vertex, because you could fold that over. It's like the axis of symmetry that makes it symmetric on each side. You don't have to graph that part though. Sometimes completing the square isn't as pretty though, right? So let's look at a couple uglier ones. Anyone have a question about that? What's the rule of when completing the square? What does the x squared term have to be? It has to be 1. If we were solving this equation that was equal to 0, we just divide through by -3 to get rid of it. But we're not solving it. There's a y over there. You can't divide by -3 because you can't have y divided by -3 over here. You have to leave y alone. Which means, you remember what we can do with these two terms that we need to get that 3 out of? Instead of dividing, what could I do that would just take that? Yeah, just factor it out. So what if I take out the -3 without dividing it, and I just put it out front? When you take it out, it's the same as dividing it. So that would leave me x squared. Watch your signs here, though. If I take -18 divided by -3, that's going to give me a plus 6x in there, right? Leave a space. I'm not taking the -3 out of the 10 because the 10 is getting kicked out to the end. So don't worry about that -3 doesn't divide into 10 because it doesn't need to. So that's really as ugly as it can get. I mean, I guess it could get like fractiony. I don't think it's do, but that would be ugly. But now we're going to complete the square the same way. What's half of 6 squared? Half of 6 is 3, and 3 squared is 9. Remember, we're trying to keep this all balanced. So if I add 9 on the inside, I have to subtract 9 on the outside. But do you remember that extra step when there's a number in front? Yeah, you have to multiply this by that number in front. And if you kind of think about why is that true, you're trying to keep it balanced. And technically, this 9 is multiplied by -3 if we worked it out. So to keep it balanced, we're going to undo it by subtracting it, but you have to multiply by that number in front. And it's just one of those little steps that you kind of have to remember. So if I factor that, half of 6 was 3, so that would be x plus 3 squared. And you can do this on your calculator. If you don't do it on your calculator, make sure you do the order of operations correctly. You should multiply before you add 10, right? Don't say 10 minus 9 is 1, and 1 times -3 is -3, right? That's not correct. Order of operations, we would multiply first and say that's 27. 27 plus 10 is 37. Questions about that? What would the vertex of this be? -3, because it's the opposite side of the inside, and 37. Not so much fun to graph, but if you had to graph one like that, just make your y-axis go like 10s or 5s or something. And your axis of symmetry would be x equals -3. If there's negative in front, means it's going to open so it's going to be a lot wider. Like instead of going over 1, down 1, you have to go over 1, down 3 because of it. Let's try this one. Do try this one actually. Factor the 2 out. That's your first step. Right? You have this and then a -5. One time I took one of these home with me. It was in my pocket, and I got the big price on it. Dang it!
Do you know when you saw them, which stole that cardigan are you wearing right now? Where the warmth inside there is that you're doing?
Did you know? No.
They'll be on our little secret club.
Like this year? One time, Sarah Woodworth was absent, and she sent a text to someone in my either calc class or calc lab, and asked what I was wearing. And so they took a picture of me and sent it to her all in class, and I never knew that it happened.
Why did she ask you what were you?
Because she's a weirdo. Like, why would she care? Like, because she was home and wondering what I was wearing for the day. So then the next day they told me that they took a picture of me and I never knew, and I was like seriously, like how am I completely unaware of things? Take the 2 out of these, and then take half of this and square it, which I think should be +4. So then you subtract 4 out here, but don't forget that you have to multiply by that 2 in front. So when you factor this, you get x minus 2 squared. And this would be -5 minus 8 is -13. So your vertex is 2, -13, axis of symmetry, x equals 2. Oh, barely. So this is way down here, but there's a 2 in front here. So if you had to graph this, you have 2 options. One option is, if this is your vertex, pick a point on either side of your vertex, plug it in, get the answer. The other option is to use transformations. Normally, when we go over 1, we go up 1. But because it's stretched by a factor of 2, it just doubles that. So I know that means if I go over 1, it's going to go up 2. Normally, when you go over 2, you go up 4. You'd have to double that. So if you went over 2, you would go up 8. it over and the other side's over here. Do you have to make that many points? No, I'm just trying to show you that you can make really nice graphs. You could also use the y-intercept on this, and we'll talk about that more tomorrow. The y-intercept's really easy if you look at it in standard form, because the y-intercept is just going to be the leftover, right, without the x. So you could very easily be like, oh, the y-intercept's -5, and that kind of gives you a free point on that graph. Questions about this? The only other thing we're doing today using standard form is kind of going backwards. What if I gave you the vertex and one of these points, and I said write the equation? It's just plugging it in and solving for a. I think there's one like that on your test once. But here we go, 2-1, we're done. It says determine the quadratic function with the following information. And I think the ones on your homework actually give you a graph, so maybe you could use that to help you. But they don't have to give you a graph. It says if the vertex is -1, -2, and it passes through the point 0, -1, write that equation. Here's what I don't want you to do, and here's what people do every year. We do this in pre-cal. I think maybe you do it in algebra 2. I kind of don't remember. But every year, people try to find the slope of this, right? This is a quadratic. We're not talking about slope, so don't find the slope. Don't use the slope. Slope has nothing to do with the quadratic equation. The quadratic equation is y equals a times x minus h squared plus k. You're trying to fill in everything but x and y, right? Your final answer should still have x and y in it. If they give you the vertex, what have they given you? Right, vertex is h and k, which means they've given you almost everything you need. Watch your signs here. It'd be x minus -1, which is where we get x plus 1 squared, and then it's going to be -2 out here. The only other letter we're looking for is a. And sometimes if they give you the graph, you can kind of figure out what a is. But if a was a weird fraction, you need to know the algebra way of doing it as well. Not slope, but what we can do is this is a point, right? This is an x and this is a y on our graph, which means we can plug in 0 for x and we can plug in -1 for y, and we can solve that for a and then plug it back into our equation. All right, so that other point they give you is so you can solve for a. So I'm going to get -1 equals a times 0 plus 1 squared minus 2. Again, the biggest mistakes I see on this, besides people trying to do slope, is sometimes they forget the squared. That's just a silly thing. But most often the mistake is they try to break the order of operations here, right? You do 0 plus 1, which is 1. 1 squared is 1. And then they want to subtract that from 2. Don't do that, right? Like this is connected with that a. So it's like saying 1a minus 2. So although it's behind the a, you can't subtract it from the 2 because it's connected to the a. And again, I'm only saying that because I've seen that mistake happen so many times. Which means I'm just solving this. I'm just going to add 2. And it turns out that a equals 1. Kind of depressing, Bill, that worked. Just did 1. That's not your answer. Your answer is write the equation. The equation would be y equals, you can put the 1 there or not put the 1 there, it's just 1, x plus 1 squared minus 2. Right, because 1's implied, right? If you put the 1 there, if it was any number besides 1, you have to put it there. But when it's just a 1, like the book doesn't put it there. So one last question here. Very similar, but I just want to point out, what if I changed up the directions, and would you know what to do to solve it? What if Courtney watches these notes, Jake? She'll know you outed her. So she came back in at the end of the day and put it back in my room?
Yeah. Well, like it's like somewhere like on that thing, in the code name, she just took it and put it on fast while she was doing something.
Does she leave at the end of the day? Like, doesn't she leave?
She's good.
Or she brought it back the next day?
Maybe.
vertex and they told you the y-intercept is in the point. Because what point would the y-intercept of -5 be? I mean -3, sorry. Right, that's still a point. So I just want to point out to you that they could kind of change the directions up on it a little bit just to see if you're thinking about it like, oh, I need a point. The y-intercept is just when x is 0, right? So that's still giving you a point. Tricky. Let me show you a shortcut or no shortcut. How far away is this x value from this x value? 1. Normally on a parabola, if we go over 1, how much do we move on the y-axis? Up 1, right? If I went over 1 and I moved up 1 from -5, where would I be? -4. So it's definitely not a is 1. You see what I'm saying on that? You see if you think about the transformations? How far did I move to get from -5 to -3? Which means what does a have to be? Oh! That doesn't always work. It just happens to be because it's right over there. See what I'm saying? The ones on your homework give you a graph that you can kind of look at the graph and see that too. If it's a nice number. If it's like 4/3, you might struggle doing that without the algebra way. I'll do the algebra way also. I'll put it all in at once. But I just wanted to show you that some people figure that out and they like to think they're smarter than me for doing that, but I'm on to it. I'm on to the tricks. Oh my gosh, I'm screwing this up. -3 equals a times x, which is 0 minus 1 squared minus 5. So you can sometimes get around the work by doing that. Well, just see if these are 1 apart, that's kind of the easy one to do, right? Like, what if this was over at 7? You might struggle in your head thinking about where would the y value be. If it's really close to the y value, then you can do it. If you try to do it and you're like, I don't know, just do that the other way. And look at the graph on the ones on your homework. The homework isn't that bad. But there was just too much stuff. I felt like I couldn't do it all in one day. These first 5 problems, they ask you like for the vertex and the axis symmetry. Let's see. Oh no, just kidding. They ask you to graph the function. But that means that 21 is already in vertex form, so it's easy to graph. But then 24, 25, 27, and 28, you have to put in vertex form first. And then 48, 49, and 50, they give you the picture with a vertex and a point, and they ask you to write the equation, which again, you can try to use a shortcut if you can, or you can just work it out. I do have a graph paper if you want it, if you guys can stick your own graph. I can tell you, I think some of these kind of have weird numbers on them, so you might have to label your y-axis differently. I think I need to make some copies of the graph paper. Oops, I didn't get the awesome graph paper.
So we should get that graph.
I ordered it. In the catalog. Anybody else want graph paper? You don't have to have it. It's your choice. It's really nice on these because you can actually remember the problem next to it and like go through your work. So. If you do the graphs on this, then yes, you have to turn this into. Don't forget that it's pride time next. I know most of you leave, so it's your day for pride time today. You get your report cards today.